And hi guys, welcome back again. Good morning guys. So now let's go for the chapter 6 summary. I know it's too many chapters that I need to summary, but I hope you won't get tired of watching my videos, every video. I hope that you will not. So please bear with me guys until the end. Fighting guys, fighting. Okay, chapter 6 on the road. See this chapter 6 clip. Bye guys. Chapter 6, network layer. What do you think on what network layer? Network layer protocols. Network layer in communication. The network layer end-to-end transport process addressing and device encapsulation, routing, decapsulation, network layer protocols IPv4 and IPv6. This is the example of IPv4 and IPv6, the exchange of data from one host to another host. As you can see, there are 4 routers on the topology part, and this application to application, host to host, characteristic of the IP protocol. Encapsulating IP. Segments are encapsulated into IP packets for transmission. The network layer adds a header so packets can be routed to the destination. IP connectionless. Sender doesn't know if the receiver is listening or the message arrived on time. Receiver doesn't know the data is coming. IP is the best effort delivery. No guarantees of delivery are made. IP media independent. IP can travel over the type of media. Network layer PDU or IP packet. This is the example of the network layer PDU. On the bottom part is the IP packet. At the upper part is the transport layer PDU. It is, and this is the IPv4 packet header. There are 4 bytes in packet v4. In the packet v4, in the byte 1 is the version, internet header length, differentiated service OS, TCP ECN, identification, time to leap protocol, source IP address, and destination IP address. Total length, flag, fragment, trust. Network layer protocol. A version is 0.1006 equals to packet priority. TTL limits life of the packets. Protocol upper layer. Protocols such as TCP, IP, source of packet destination. IPv6 packet. Limitation of IPv4, introducing IPv6, encapsulating IPv6, and the IPv6 packet header. As you can see the meaning of the brief meaning of limitation of IPv4, introducing IPv6, encapsulating IPv6. Next is the network layer protocol. This is the example of IPv6 packet header. The version of the IPv6 is 0110. Traffic loss is equal to priority. The flow label is the same. Flow will receive the same handling. Payload length is equal to same as total length. Next header equals to layer 4 protocol and the hop limit. Routing the host. How a host routes. Host forwarding decision. 3 types of destination itself and local host. Remote host default gateway routes traffic to the other networks. Has a local IP address in the same address range as the other hosts on the network. Can take data in forward data out. Using the default gateway, host will use the default gateway when sending packets to remote networks and the host routing tables. Routing. This is the example of the routing. There are output command, and this will be the function or in the routing command you have how a host routes router routing tables. First, you need to route a router packet forwarding decision, then the IPv4 router routing table, directly connected routing table entries, remote network routing table entries, remote routing table entries, and the next hop address and the next hop address. Next destination, the specific destination of the route address. Routing. So you can see the branch system of the router packet forwarding the decision. IPv4 router routing table, directly connected routing table entries, and remote network routing table entries. The next part is the the R1 IPv4 routing table. So this is the topology of an IPv4 routing table. This is how the router connects, how the PC connects to the router. Routers. Anatomy of a router. A router is a computer. Routers have CPU, memory, and I/O devices. Cisco routers use iOS as their operating system. Router memory. Just as a computer, routers have memory. Router contain RAM, ROM, NVR, RAM, and flash memory inside a router. Connect to a router, LAN, and interfaces. Inside a router is the routers have the same general structure. Connect to a router. Routers have many ports. Support connections. LAN 1 interface. Anatomy of a router. Boots. Life of list files. iOS image file stored in the flash contains the iOS router boot up process. Show version output. The show version output is very common and very useful. It provides information on the amounts of memory installed, what iOS images. was loaded during the boot. This is the example of a RAM during boot up. You need to configure IO. Configuring a Cisco router. This is the sample switch configuration of a Cisco router. So you can see the PC needs to connect to the switch until to router, and router to router. So they have this kind of configuration router. So this is how you connect the configuration in router. Configure interfaces. To configure router interfaces, enter the interface sub-configuration mode. Add a description to the interface. Configure an IPv4 or IPv6 address. Activate the interface with a no shutdown command. Verify interface configuration. Show IP route, show interfaces, and the show IP interface. Show IP route displays the contents of the IPv4 routing table stored in RAM. Display the interfaces is the display statics. This is the example of the default gateway for a host. So PC1 to PC2 are connected, then connected to the switch, while the PC3 and the PC4 is connected to another switch, while the two switches is connected to the router. So they can, in the ping remote host, PC1 can connect or can deliver a message to the PC3. As you can see, they are connected. They can be connected because of the switches that they are using. So that's all for the chapter 6. I hope you understand. So that's all for chapter 6. I hope you have learned something from me, and I hope what I have presented to you is given a thumbs up. Okay, bye guys, see you next time.